So your last video on solving inequalities. So rational, remember, means fractional. And these are very similar in a lot of ways to solving polynomial inequalities. But there's one major difference which we'll get to. Now, the first step in blue, you must pull all your fractions to one side with 0 on the other. You've got to combine multiple fractions into a single fraction. You want to then try to factor the top and the bottom of the fraction if it's possible, and identify the critical values, use a sign chart, and answer with intervals. Here's what you want to do. With equations, we want to clear fractions. But with inequalities, you're not allowed to. So you've got to commit to memory. Equations, you clear. Inequalities, you don't. So otherwise, it's very similar. So I'm going to go through 3 examples with you. Once you get the hang of it, life's going to be good. Okay? But I'll show you what not to do on some of the next 2 problems. So on number 1, we already have a single fraction on the left and 0 on the right. So we're perfectly set up. Furthermore, the fraction on the left is already factored on the top and factored on the bottom. That is muy bueno. So what I've got to do now is identify the critical values. Well, what x value would make the top of the fraction go to 0? Do you see that it would be x equals -3? What x values would make the bottom of the fraction go to 0? Do you see it would be x equals -5 and +1? So you have 3 critical values. So the critical values are any x's that make the top or the bottom go to 0. So from here on out, it's going to be exactly like polynomial inequalities. So I'm going to say, well, on the number line, I'm going to have 3 dividing bars. -5 goes on the leftmost, -3 goes on the middle, and 1 goes on the rightmost divider bar. So now I'm going to sweep through and pick out test values. So I'm going big. I'm going obvious right here. 0. 0 is always good. And I'm going big on the other end. Okay? You're still going to plug in. So if I say -12 plus 3 on the top, I get a negative on the top of the fraction. On the bottom, I would say -12 plus 5 is negative, and -12 minus 1 is negative. And whether I multiply or divide by an odd number of negatives, the result's negative. On the top, for -4, -4 plus 3 is negative. -4 plus 5 on the bottom is positive, and -4 minus 1 on the bottom is negative. So 2 negatives make a positive. When I plug in 0, 0 plus 3 on the top is positive, 0 plus 5 on the bottom is positive, 0 minus 1 on the bottom is negative. So 1 negative makes a negative. When I plug in 19, I have 19 plus 3, 19 plus 5, 19 minus 1, and it's all positive. Now, this problem would be tricky if it was greater than or equal to. But if it's just greater than, it's all open circles and there's nothing else to worry about. We have to be careful if it's greater than or equal to, or less than or equal to. But if it's just greater than or it's just less than, just put a bunch of open circles and life is good. Greater than means positive. So I'm going to put my positive, and I'm going to quickly write that interval solution, and I am bound for my second problem. Now, on the second problem, I'm going to throw in more algebra on the front end. So I'm looking at this, and I see that everything is on the left with 0 on the right, but I don't have one single fraction. I must combine fractions. So I'm going to have to say x plus 1 over x plus 2. Now remember, 4 is like 4 over 1. So if I had 4 over 1, then I would have to multiply the top by x plus 2 and the bottom by x plus 2 in order to get a common denominator. So this is good because we're reviewing how to work with fractions. So that's going to give me x plus 1, distribute the -4 and get -4x minus 8, and it's going to be over the common denominator of x plus 2. So on the top, that gives me negative 3x minus 7, boo, yucky number, over x plus 2. Now on the top, I'm double checking my arithmetic just to make sure. That's why I paused for a minute. On the top, you could factor out a negative, but it's not actually real helpful because it doesn't make things a lot easier. So I'm just going to leave it like it is. So I need my critical values. Well, the bottom critical value is easy. So I'm being chicken and doing my easy stuff first. But on the top, I have to say, wait a minute. If I want the top to be 0, that means negative 3x equals 7 and x equals negative 7/3. Boo! That is an ugly critical value, but you know what? We're mathletes. We can deal with it. So remember, negative 7/3 is the same thing as negative 2 1/3. Okay? That might help you. Sometimes it's easier to look at the mixed and sometimes it's easier to look at the improper. You're going to get better at working with your numbers in this class because you'll have to. But we'll talk a lot about making smart choices. So anywho, when I go to my sign chart, I've got 2 dividing bars. One at negative 2 1/3 or negative 7/3 and one at negative 2. So I'm going to put 0 there for sure. And negative 7/3, I'll just go big and say negative 10. So it's the one in between them that's a little weird. So what's between negative 2 and negative 2 1/3? Do you see that you could use something like negative 2 1/4 or negative 2 1/5? So if I use negative 2 1/4, that's the same thing as negative 9/4. So having both versions of the fraction in front of me could help me move a little faster with things. So that's why I'm writing both. So now I'm going to plug in, and when I plug in, I'm going to plug into the most simplified version of the answer, or of the fraction. So on top, negative 3 times negative 10 is 30, and 30 minus 7 is positive. On the bottom, negative 10 plus 2 is negative, so I get a negative result. I'm going to do the other easy one because, again, I'm being chicken. So on the top, I get negative 3 times 0 minus 7. That's negative. I can see that quickly. On the bottom, 0 plus 2 is positive. So that's negative. My gut feeling is it probably goes minus plus minus, so the middle's going to be positive, but let's work it out. So if I plug in negative 9/4, let's do some scratch work. I've got negative 3 times negative 9/4. Here, I'm going to do my scratch work and then I'll erase it. So that's going to be 27/4. 27/4 minus 7 is minus 28/4. Well, that's negative. Phew, glad the top is done. On the bottom, I can see that if I use negative 2 1/4 plus 2, it would be negative. So see, on the top, it was easier to work with the mixed or the improper fraction. But on the bottom, it was actually easier to work with the mixed fraction. So being able to kind of bounce back and forth about what you use speeds you up. And that's part of what you're learning in this class is how to get good at rolling through problems. That's what I'm trying to teach you this year. So when you look at it, I see that it's less than or equal to 0. Now here's where things get tricky. So be careful. Number 1, less than 0 means negatives. So I know already that I'm going to get this area and this area of the number line. But guys, in a polynomial, you can just put closed circles everywhere. You can't put closed circles everywhere in a fraction because if your x value makes the fraction equal to 0, it's a solution colored in. But if your critical value plugs in and makes your fraction undefined, then it's not a solution. Well, guys, notice if I plug in negative 7/3 to the fraction, then I would get negative 3 times negative 7/3 minus 7 over negative 7/3 plus 2. That's going to be positive 7 minus 7, 0 on top, and it's going to be negative 1/3 on the bottom. So that's equal to 0. So negative 7/3 makes the fraction equal to 0. So I color it in. But if I plug in negative 2 to the fraction, I get 6 minus 7 is negative 1 on the top and 0 on the bottom. That is not 0, that's undefined. So negative 2 doesn't make the fraction negative. It doesn't make the fraction equal to 0. So this is not a solution. So open circle. So in general, critical values that come from the bottom are not solutions. So leave them open circle. You'll only ever close circle a critical value that comes from the top. But that you only close anything in if it's an equal to 0, less than or equal to 0, or greater than or equal to 0 problem. All right, hard part's over, guys, so let's rock it. Now we know it's negative infinity to negative 7/3, bracket, union parentheses, negative 2 to infinity. So I'm zipping your last example of the day because I know you're probably, tired at this point. All right, on this problem, what you need to do is say 3 over x minus 1 minus 2 over x plus 3 is greater than or equal to 0. Now, you could have pulled everything to the right side instead of the left side, FYI. Now, those are two separate fractions. You've got to get everything into one single fraction, so you've got to subtract your fractions. Well, if I subtract my fractions, my common denominator has to be x minus 1 times x plus 3. That means you've got to multiply the first numerator by x plus 3, and the second numerator, so minus 2, times x minus 1, and it'll be greater than or equal to 0. So now just keep cleaning things up. So on the top, you've got 3x plus 9 minus 2x plus 2. You got to clean the top up before you can see if anything cancels out. So on the top, I get x plus 11. Oh my gosh, that's such a pretty numerator compared to the last problem. Guys, this problem is not going to be difficult because the top and the bottom are already totally clean and factored. So our work's going to be like, fast on this. So what are your critical values? You've got 3 overall. Do you see negative 11 on the top, 1 and negative 3 on the bottom? Hope so. Now, we need to do our number line. We need to do our sign chart. So I've got 3 divisions, 3 divider bars that I need to create. I've got negative 11 to the left, negative 3 in the center, and 1 on the right. Pick your test values. I'm saying less and less because I'm hoping you're kind of taking it and running with it at this point. See if you can do your sign chart without watching me, and then double check and watch me, make sure we got the same thing. That would be really cool if we could match up. All right, when you're ready, look at what I did. Did you get the same thing? If you did, that means you are coming right along with your understanding of the concept. Yay for you. Now, the next thing is I need to remind you it's greater than or equal to 0. So be careful. Don't just go around coloring everything in. What x values are you allowed to color in? If you said the x values from the top, you're right. So negative 11 is allowed to be colored. But negative 3 and negative 1, or positive 1, when you plugged in, would make that fraction be undefined, not 0, so they are not solutions. Coloring them in indicates that they are solutions, but they are not, okay? So greater than 0 indicates positive, and you're going to get bracket -11 to -3, union 1 to infinity. Now, I know that you don't want me saying anything else because you're tired, but let me say something that you need to understand. If this were an equation, I would want to clear fractions. And the easiest way to clear fractions on a proportion, because it's fraction equals fraction, is to simply cross multiply. So you'd have 3x plus 9 equals 2x minus 2, and you'd have x equals -11. All right? That's great for an equation. It does not work on this. So somebody that tried to take this inequality and simply cross multiply would run into a roadblock, because if you cross multiplied it in one direction, you might have 3x plus 9 is greater than or equal to 2x minus 2, and you come out telling me that x is greater than or equal to -11. That's not the answer, guys. And so when you cross multiply, you lose a lot of the information in the problem that you need. And let me be clear, if you do this and you don't recognize this is a sign chart problem, then you've boxed yourself in where I cannot give you partial credit. So that means you don't know the process and you don't practiced enough to recognize what process to implement. So please, please, please recognize cross multiplying and clearing fractions is for equations. Getting to a single fraction using common denominators is for inequalities, and that's what we've got to do here. So remember, the minute you see rational inequality, think sign chart, and that means you need critical values from the top and bottom of your fraction, and that should help you keep it straight. Good luck finishing your assignment, and I'll see you tomorrow.